If we're gonna make our buildings and the people inside them resilient to the impacts of climate change, and if we're gonna succeed at slashing the greenhouse gas emissions caused by these buildings, then we're gonna need to retrofit existing buildings, and a lot of them. That's what makes Julie Klump's work on the Salem Heights Apartments north of Boston so exciting. She and her team at Preservation of Affordable Housing are gunning for a Phius certified passive house retrofit for this 281 unit low-income housing project. And they're doing it without displacing residents from the building. Let's find out how.
Hi everybody, welcome to Salem Heights. We call this project the Salem Opportunity because most of the exciting things we got to do were because of the building condition. I'm Julie Klump, Vice President of Design and Building Performance at Preservation of Affordable Housing. We bought this building like 15, 16 years ago. When we bought it, the acquisition costs resulted in us not getting to spend the money that we like to spend per unit when we do an acquisition rehab. So 15 years later, we get another bite of the apple for tax credits, and we're able to really do some damage. When we started this project, we were gonna reattach the brick. The brick had some cracks. We didn't realize how extensive it was. And we were gonna do a lot of unit turns. So we start doing some brick openings just to see how we were gonna reattach the brick. And the structural engineer said, the brick's gotta go. So that gave us a chance to overclad. And we planned on redoing the windows, so that's a given, but we did use high performance windows. So what we decided to use was an armor wall. It's kind of new to the market, but I think there's lots of projects using it. It's a structural insulated panel. We chose the highest we could get, which is an R21. So it's I think it's polyiso insulation with structural sheathing on it. It does also have a fire protection membrane on it. Once you seal all the anchor holes and seal all the joints between it, you also have an air and water barrier. So we went from probably an R4 to a R25 wall, which was huge. We got new triple pane windows. And then over the top, we're cladding it with a metal panel. And we chose the metal panel mostly because we didn't want to come back up here and have to repaint. We're not very far from the ocean. We're high on a hill, so we wanted something super durable. The other good thing about being high on a hill is if you can see from this side, we actually have vertical PV. So in lieu of the metal panel, where we had a south or a southwest facing elevation, we attached PV panels. Behind the PV panels, we did have to do a UV protection on the armor wall, but that's the only difference in the cladding there. You can see sort of before and after. Using mass climbers, it's a pretty tall building. It's pretty complicated. We've got a lot of interior work going on. Every sheetrock joint in this building is hot, so we've had to do abatement. We come into a unit, we abate the exterior wall. So what we've had to do in terms of occupants, usually we do occupied rehab, but because of the abatement and because of COVID, we decided that what we were going to do was to create hotel suites in 2 stacks up and down the building. So people stayed on their floor, but they would move into that hotel, one of those hotel suites, and we would work in their units. So people just keep using those hotel units until we're done doing all the interior work. It's going to be roof solar as well. We'll probably generate about 300 kWh per year, but that's probably barely half of our electric load. When we go inside, you'll see we've kept the baseboard fossil fuel boiler heat and domestic hot water. The Minutair may be able to pull it off because of the robust enclosure, but we want to give it a season or two to see if the Minutair can keep up with the heat needs. And for those of you not familiar with the Minutair, you'll get a chance to look at it. It's heating, cooling, and ventilation in a box. And it's got some fancy duct work that's really quiet, requires condensate. It has a controller, not a thermostat, but we'll go in and you guys can take a look. The current system is a rooftop unit that didn't provide any cooling, but provided tempered air that dumped into the plenums above all the units on each floor. And then there was a small, like 6x6 register above the door that we measured years ago, and in most cases there was no air flowing through that register. So system, I'm sure it's been off for years just because it doesn't work and it costs a lot of money to run. So we looked at using some of the vertical stacks to provide air into the corridor and then run down the corridor and into each unit on opposite sides of the hallway. Because of the steel beam, we realized that was not going to work. That would also have required us to install a cooling system, which would have been a little easier. We could have run refrigerant a lot easier than we could have run ducted air. So we looked at the Minutair. It sort of answered all of our needs at the time. It takes up a little bit of room because we had to build a closet, but the air quality is amazing. It's pretty, as complicated as it seems, I think it's a pretty simple unit. There are filters that have to be changed during the year. There's a tenant setting on the controller so that we can limit the confusion and just have residents adjust temperature in their unit. So that's sort of where we landed with heating and cooling. We still have we have a relatively new fossil fuel boiler system that makes hot water and heat. We left the radiators in that provide heat. They'll be connected to the Minutair so that they'll never be competing. We are trying to do passive house. We've talked to Phius. We did a blower door test to sort of isolate a floor, isolate some units. There's some other the subsequent, or the other requirements for Phius certification that we can't hit in a rehab, but they're excited about seeing where we get. So we're going to do the best we can on air infiltration, but it should be a huge improvement.
If you want to see more cool examples of building resilience and decarbonization, then hit that subscribe button. Until next time, thanks for watching.